Hi dear students, welcome to the next topic from laws of motions, and today we are going to see few problems which are normally coming for your NEET and JEE examinations. So last time we have learned lot of concepts like different shapes of different body, how it's look like, whether it is both sides are hanging, one side rest over a table and another side is hanging. So we have seen lot of examples like including the pulley system also. So today we are going to try with certain examples. I have a list of questions with me. So we will try these examples so that the concept what we have learned will be there clear. Okay. So before going to this topic, I want to once again to give a refreshment for you in terms of the laws or the rules we have learned for drawing the free body diagram. The first one is tension forces are always away from the body, and the second point is contact forces are always towards the body. I hope you know contact forces are whenever there is a real physical connections are there, there is always a contact forces will be there, and the contact forces are always towards the body and tension forces are always away from the body. And the third one, tension into acceleration is constant. Tension to acceleration is constant means the net sum of tension into acceleration. If it is a two block system, then T1 A1 equal to T2 A2. If it is multiple blocks are coming, like maybe more than some 3 blocks or 4 blocks are coming, in that cases you have to have a tension into acceleration. You have to find out for each part and you have to add it up, and the total sum is constant. Constant in the sense here, constant means tension into acceleration. Sum of tension into acceleration is equal to 0. Okay, or T1 A1 equal to T2 A2 by comparing both sides, or overall the system level tension into acceleration is constant. I will just write down the rules once again here for your understandability. Number one, in short, contact forces normally will say it is always towards the system. It is always towards the system. This is the point number one. This is already we have written, but I am just writing. Tension is away from the body. In short, I am writing tension is away from the body. This is the second rule. And the third rule, I can say summation of, for a system level. This is applicable for more than 2 or 3 bodies. If it is 2 bodies, T1 A1 equal to T2 A2. But generally, in general equations, we can remember T dot A. A dot will be there, which means the angle between tension and acceleration is equal to constant, in the sense 0. Okay, constant means T1 A1 equal to T2 A2 for a 2 body system. But if multiple bodies are coming, summation of tension into acceleration is equal to 0. So these 3 rules are important to solve the problems. This is what we are going to apply in the coming examples. So I have a few set of examples for you from different models, and today's the aim is we will going to solve these examples and analyzing each problem in a deeper way. Okay, so we will start with this one. So I have certain questions, certain examples. Normally I will say with the problem with an example. So we will solve with the first example. Okay, so I have a first examples with me. Example number 1. Example number 1 indicate if there are, okay, let me take my questions back. So we'll go one by one questions. So the first question is based on, we have a surface will be here, surface will have a block M will be here, and top of this one another block M will be here. Okay, the question is find the reactions between capital M and ground. Find the reactions between capital M and ground. This is the question. So what we have to do, we have to find the reactions. So here bodies are directly connected, so contact force will be here. So what is our first step? This is the question. We are answering this one. First one, we will draw the free body diagram of M1. First free body diagram of M1 we are drawing will be here. So tell me, what is the free body diagram of M1 will be in this case? M1 in the sense the first M body. So small letter M. M will act a force called mg, and this will have a contact force. Okay, contact force will be here. Here contact force equal to reactions. So I am giving this as N1. Okay, no other forces. it is not, the block is not moving, so upward force minus downward force will be equal to block is not moving, so it is 0. So I can say N1 is equal to mg. So first stuff is over. Next, I am going to draw the free body diagram of capital M. Free body diagram of capital M. In the free body diagram of capital M, we have a capital M block will be here, and this will act as some force. What is this force? Capital mg. Okay, and here this is also a contact but with the ground, so there is a contact force will be here, and that contact force is called normal reactions N2. Okay, so on top of this body, what is available will be here between this interface. There is a reaction, reaction, or I can say there is a contact force. That contact force are always towards the body. What is that contact force value will be equal to N1. Okay, contact force N1. Now we'll write the formula N1 plus mg is equal to N2. What is N1? We already find mg. So this is capital M. So it is small letter mg plus capital letter mg is equal to N2. So N2 is the reactions between the M and the ground. So which means small m plus capital M into g is called N2. This is the answer for the question. This is the reactions between the ground surface and this one, which means our value of N2. So N2 is equal to small m plus capital M into g. This is for a two body system. If you have three bodies are coming, the system will be varying. We'll see with so hope this is very clear. This is kind of problems. I'll call it as stacked bodies, stacked one after another. This is something called stacked bodies, which is placing on top of another, which is called stacked bodies. We'll see the second example in the same format, but a little difference. Okay, so we'll move to the second example. So this all concepts are related with the stacked bodies. This is called a stacked body. Stacked means one body is placed on top of the other body. That is called a stacked bodies. So we'll move to the next question. I have another questions to you from stacked body concepts. So it is like a three blocks will be here. So write example number 2. So I have a 3 block system. So bottom part is 5 kilogram, and it is 3 kilogram, and it is 2 kilogram. Okay, 2 kg, 3 kg, and 5 kg. Okay. Here also we have the same question. Find the reactions between ground and 5 kg. This is one question. Okay. So what we'll do to understand this betterly, we'll start with the free body diagram of 2 kg first. Free body diagram of 2 kg. So 2 kg will be here. What is up acting downward? Mg. Weight will be there. And here there is a contact force, and this is I am assuming N1, and this contact force is N2. Or you can assume like F1 and F2. That is also fine. Why I am assuming here N1 and N2 is like here normal reaction is equal to the contact force. Okay. So N1 is always towards the body. So N1 is always towards the body. So N1. So we'll write the formula N1 minus 2G is equal to 0. So N1 will be equal to 2G. So we got this one. Next we will go to draw the free body diagram of 3 kilogram. So 3 kilograms body will be here, and 3 kilogram body, of course 3G will be here. N2 and N1 will be there. N1 is towards the body and N2 is also towards the body. These are the contact forces which are acting towards the body. So now we can apply the formulas will be here. N2 upward forces, these two are downward. So N2 minus N1 minus 3G is equal to 0. So N2 will be equal to N1 plus 3G. What is N2? What is N1? 2G. So N2 will be is equal to 5G. N2 is equal to 5G. We are substituting for N1. So N1 and N2 will get. Here we have our third contact force, which is called N3. This is what we need to be find out. Find the reactions between ground and 5 kilogram surface. So for that we now got N1, we now got N2. What we need to do? We need to get N3. N3 is the question. For that, what we need to draw will be here. We need to draw the free body diagram of 5 kilogram. So we'll draw the free body diagram of 5 kilogram will be here. Okay. So we'll draw the free body diagram of 5 kilograms block. Okay. So a free body diagram of 5 kilogram blocks will draw. This is 3 kilogram. Okay. So 5 kilogram. Tell me what all the things will be here. Downward 5G, contact force N3, and here because of this N2 is another contact force towards the body N2. So we'll write the formula 5G is downward, or I can say N3 is upward. So based on that I can write N3 minus 5G minus N2 is equal to 0, or I can say N3 is equal to 5G plus N2. What is N2 value? N2 is also will be equal to 5G. So N3 will be is equal to 5G plus 5G, which is equal to 10G. So N3 is equal to 10 times of G value. In entrance examinations we are taking 9 meter per second square. If you are taking that value, then 10G, 10 into 10, you will get value is equal to 100. Okay, this is what we have learned before. It is a application of our first law, contact forces, but here contact force will act as in terms of normal reactions. That is the difference will be here. So we'll move to the next question then. Okay. So this is our second example. So first example we have seen like we have connected 2 bodies, and in second example we have learned about we have connected 3 bodies. It is not necessary that it should always ask like 2 bodies or 3 bodies. It may ask with any number of bodies which are connected each other. Okay, so we'll see another examples similar to this, but bodies are connected in horizontal fashions. Okay, so let's assume our example number 3. Okay, so we have a 5 kilograms block, a 5 kilogram. On top of this one we have placed another 2 kilogram blocks, and this is pushed with a forces equal to 10 Newton. Okay, assuming all the surfaces are assuming, so write along with me, this is a question. Assuming all the surface are smooth, all the surface are smooth, double O, right, smooth, find the time in which 2 kilogram blocks falls off 5 kilogram blocks. That's a question. Okay. Okay. So here what we can see, like we have a 5 kilogram blocks, on top of this one 2 kilogram blocks will be here. So 2 blocks will be placed, again it is stacked, but instead of asking reactions, some force will be given 10 Newton. So what will happen in this scenario? If I am pushing the 5 kilogram blocks like this one, what will happen? The above one, this 2 kilogram block will move back and will fall off. Okay, and the length of this block will be equal to 4 meter. So I have to see, assuming all the surfaces are smooth, because there is no friction. We will going to learn about the friction later. There is no friction. Find the time in which 2 kilogram block falls of 5 kilogram, which means I am pushing the 5 kilogram block. So what will happen? The 2 kilogram will travel this much distance. What is this distance? 4 meter distance, the 2 kilogram blocks will travel and it will fall off. So to travel this 4 kilogram blocks in backward direction, how much is the time taken by the 2 kilogram blocks? That is the questions will be here. So we need to actually find out the time taken by that blocks. That is our intentions to find out will be here. What is the time taken by that blocks with respect to the another blocks? So here again we have like a 2 free body diagram. We have a 2 kilogram and we have a 5 kilogram blocks will be here, and we have to draw the free body diagram of both of this one. So first we'll draw the free body diagram of 5 kilogram. Free body diagram of 5 kilogram. Suppose I am assuming the 5 kilogram block is moving with an acceleration of a1 and this is moving with an acceleration of a2. I know it is in the backward direction, sir, but at the moment I am just marking like this one. So 5 kilogram blocks, 5 will be here, and we are applying a force of 10 Newton, and this is moving with an acceleration of a1, Okay, and we have, of course, here we have weight and reactions will be here, but that doesn't depends upon this acceleration. So total force equal to mass into acceleration, which means 5a1 will be equal to 10 and a1 will be equal to 10 by 5, which is equal to how much? 2 meter per second square is the acceleration of this one. So 2 meter per second square is the acceleration of the first block. So if the first block is moving, of course, the second block is placed on top of this one. So I can say A1 is in the positive direction with a speed of 2 meter per second square it is moving. So in that cases, what is the relative accelerations? So here A1 will be equal, okay, if I'm looking from, just to think logically, okay, this block is pushing, so this blocks will move with a speed of 2 meter per second square. So if it is moving, the another one is pushing in the backward direction. So acceleration of the second block with respect to which block? With respect to the first block. So I'm not giving you much confusions. Definitely I know this is moving with the 2 meter per second square, other one is moving backward in the direction of 2 meter per second square, because one is forward and another one is in the backward directions, because both the forces are acting, the forces are acting on a 5 kilogram blocks towards the forward side, but the other one, the forces are acting in a reverse directions. Okay, here even though if I mark it, A2 will be like this one, this is not moving like this one, right? This is moving like this. So A1 accelerations I know, so A2 acceleration will be negative of this 5 kilogram blocks. Okay, now we know the distance traveled by 2 kilogram blocks. What is the distance traveled by? Equal to 4 meter. Now we have to learn some equations from your one dimensional motion. S will be there, A will be there, you need to find out acceleration. Final velocity, initial velocity, nothing will be there. What is the only equations you have? S will be equal to ut plus half at square. Starting from rest, initially it is not moving, only applying the force only it is moving. With a distance of 4 meter it is moving, and 1 by 2 into acceleration is minus 2 for this block. This block it is a minus 2 into t square. So t get cancels, minus 1 will be here, and t square will be equal to t square. So minus t square will be equal to 4. Minus t square will be equal to 4. So what is the value of this one? So what is minus indicate? Minus will be, here it is talking about the time. So here the minus sign indicate will be the block is moving towards left side. So time will not be, if you're taking will be a t square equal to minus 4. So no, time should not be negative, and this minus signs indicate the block is moving in opposite directions. The block is moving opposite direction. So from here to here the distance is 4 meter. Always we are measuring from left side. If you are measuring from right side, if you are considering this as displacement, you can take it this as minus 4. So time should not be negative. Why the minus sign is coming here? Because of this direction is opposite. So if you take time is positive, time is always positive magnitude wise. So t square equal to 4 and t is equal to 2 seconds. Okay, you can take magnitude here because the minus sign coming because of the acceleration direction. So the time is independent of direction, time is a scalar quantity. So you can take a magnitude. So t square will be equal to 4 and t is equal to 2 seconds. So within 2 seconds the block will fall off. This model of questions are very common for entrance examination, because we are not doing anything will be here. We are drawing the 5 kilogram block diagram and we have drawn. We know it is moving with a speed of 2 meter per second square. So the other block will be on top of this 5 kilogram block. So one block is moving in forward direction. Then the other block which is on keeping on top of this one will going back, right? Okay, suppose this is my phone and I have kept this pen will be here. If I'm pulling my phone very fast, my pen will be sliding back. So the same story is happening will be here also. So you are pulling with 5 kilogram and 2 kilogram is coming back. That is actually happening will be here, and we got one acceleration. So the other acceleration is also same because it is the same forces acting on this but in opposite direction. We are finding the time. So we are make use of this width, this length of this 5 kilogram block in order to apply for this equations, because I want to know what is the time taken by the body to cover certain distance. What is that certain distance will be here? 4 meter. Okay, hope this questions to it is clear to you. So we'll move to the next examples. Now third example is over. We'll move to the further examples. Okay, hope this is clear to you. Stacked bodies, any models can ask, but yeah, these are the some of the common questions are coming for entrance examination. I just note on, and the same stuffs will be will ask when you are dealing with the friction also. Now we are not dealing with the frictions, right? We are not entering to friction at all. When we come to friction, there is slightly some extra additions will be there. There is nothing more and nothing less will be there, just an addition of these two stuffs. Okay, so we'll do the another question. So example number 4th example. Okay, so like how I can say, we have a block like this, and here we have a 2 kilogram, and we have a fixed pulley like this, and we have a mass is hamming whose mass will be equal to 5 kilogram. Okay, two questions will be here. This is a rigid surface, so you can write the questions along with me. Find the acceleration of 5 kilogram block. Find the acceleration of 5 kilogram blocks. Okay, so this is like a two body system. There is one pulley connected. So we know there are two shortcut formula, one for acceleration and one for tension. Question is asking about accelerations. So we'll find the accelerations. So acceleration is equal to forward force minus reverse force divided by sum of the masses. This is our shortcut formula, SC shortcut. Okay, so what is the forward force? Forward force will be like this, 5G. So forward means, reverse means in this direction. Any opposite forces? No opposite forces, only forward force. 5G divided by total mass 7, 5 plus 2, 7. So acceleration is equal to 5G divided by 7. Question is asked only about the acceleration. If question is asking about the tension, then tensions we have a formula, shortcut formula, forward force into reverse mass plus reverse force into forward mass divided by sum of the masses. I am just finding additionally tension. Tension is not asked in the question, but just for our use, our understanding purpose. What is the forward force? 5G. What is the reverse mass? 2. What is the reverse force? No reverse force. Here also it is reverse force 0. So that is 0, and it is 5 plus 2, 7. So 5G into 2 means 10G divided by 7. Tension the unit is Newton. Acceleration the unit is meter per second square. So acceleration is 5G divided by 7 meter per second square, and your tension is equal to 10G divided by 7 Newton. This is what the story. Okay, all the stories are happening based on this connection. So this is just a direct questions. I say there are not much things which are just like, I mean, confusing you will be here. It's not nothing. There is nothing confusing will be here. Okay, there is no complexity, nothing, just direct questions, whatever you have learned based on the rule. We'll move to the next question. So draw this diagram also. We have a pulley, and this pulley is fixed, and we have a rope is connected over here, and this rope is over another body, and this body will be here, another body, and this is connected over another body will be here, and this body will be here, and this is a fixed pulley. Pulley is not fixed, pulley is fixed, and this pulley is also a fixed pulley. Okay, a fixed pulley, and this is a surface. Okay, and the masses of each of this one will see, this is a 5 m mass, not 5 m, 5 kilogram mass, and this one is 2 kilogram mass. Okay, question is given that this is a diagram. This is our example number 5. Okay, 5th example. Question is, so I am writing the question, find the acceleration, find the acceleration of 2 kilogram block. Find the acceleration of the 2 kilogram blocks. Here this is not like the previous question. Okay, here we have a 2 pulleys are there. So we cannot use our formula as such will be here everywhere. Our shortcut formula is like I told, forward force minus reverse force divided by for some of the masses, that we can use it if it is one pulley and with the two masses are connected. In a simple system you can use it, but this is a little an advanced system. So here the logics what we are going to apply or what we are going to use means, first point is here we have to mark the tension. That is our first aim. I will mark the tensions. Listen very carefully. So this is called tension. Okay, so tension I have marked will be here. So first we'll mark about the tension, then we'll mark about accelerations. So this tension will convert it. Any other connections in the diagram? No other connection. So with respect to this body, tension is away from the body, and here also we have tensions will be here, and tension is with respect to this body, it is away from the body, and with respect to pulley it is away from the body. Okay, so we have to find the things which are marking, and we have to draw the free body diagram of each of this one. So we know 2 kilogram block is moving downward, so this value is an acceleration of A. So if it is if you are not sure about the acceleration value, you just give A1. You just give A1. So you are not sure about the acceleration value because it's a complex system. It may be same, it may be different, I don't know. So I am giving this value as called A2. That's all. Now we will apply the concepts will be here. Okay, before going to draw the free body diagram, if the question is a complex question, then the rule number 3 will apply will be here. Our rule number 3. What is the rule number 3? Summation of tension dot acceleration is equal to 0. Remember always, this is a system level. T1 A1 is equal to T2 A2 is equal to T3 A3 for a like each block to block we are comparing, but remember this one, then it will be easy for you always. What you have to do means dot product means cos theta will come. So now if you see how many accelerations you have 2 accelerations are there, so you have 2 terms will be here. Okay, so first I will go with this one. Okay, tensions will be always with respect to rope, you can mark it as such it is. First we will see will be here from this one. So tension is upward, acceleration is downward. Okay, here tension is upward, acceleration is downward. You remember this method, so you can easily find an answer in a short time and you can do a better performance in the examinations. So tension is upward, acceleration is downward. What is the angle between them? Theta will be equal to 180 degree. Same direction 0 degree. Opposite direction it is 180 degree, which means in opposite direction. So T dot A means A1, angle, cos of angle between them, what is called 180 degree. Sigma means plus. Will be here. Here tension. The block will definitely move like this. Okay, so tension into acceleration. Acceleration is A2. What is the angle between them? Both are in the same direction means cos of 0, which is equal to 0. Okay, so tension into acceleration is constant T A1 cos 180. So T A1 cos 180 minus T A1 plus cos 0 is 1. So T A2 is equal to 0. So now we got one assumption from this one. What is that? A1 is equal to A2. So now we got one assumptions. Okay, so there simply from this analysis I got A1 is equal to A2. Initially I don't know. That's what I am taking A1 and A2 difference. Okay, now I know A1. Now first I will write the free body diagram of this one. I will write the formula. Okay, so free body diagram of which kg? 5 kg blocks. So we have a 5 kg blocks like this one. Okay, tension is in this direction, acceleration is in this direction A2. Any other forces? Nothing will be here. So left side, everything will be left side. So minus T will be equal to minus 5 A2. Total force equal to mass into acceleration. If it is left side means both are negative. So I am writing T is equal to 5A2, or I can say T is equal to A2 is what? A2 is equal to A1. We got both are same. So I am assuming A1 will be equal to A. If so, then what is A2? A2 is also equal to A. Okay, so I am assuming, so T is equal to 5A. This is my first equation. Next, I am going to do the free body diagram of which body? 2 kilogram mass. Free body diagram of 2 kilogram. So 2 kilogram upward forces T, downward forces its weight will be here 2g. Here also weight and reactions will be here, but it is nothing to do with acceleration. For this 5 kilogram, you can draw 5g and the normal reactions n, but it is nothing to do with the acceleration. That's what I skipped it out. Whatever I required, only I have marked, and rest of the things I forgot. Because here I have marked n is equal n and 5g. So n is equal to 5g. What can I do with that acceleration? No use. It's useless. So I don't want to mention such unwanted things unnecessarily in the diagram. It's not required. That's what I intentionally skipped, but here it is required because it has a connections with the tension. So T minus, tell me 2g, what direction body is moving? Downward directions. So it is minus 2a1. Okay. So what we can do? We can equate the tensions. So T is equal to 2g minus 2a1. So what is 2g? 2g minus what is a1? a1 is equal to a. So it is 2a, tensions left side. So we got two equations. We got two equations, one from the 5 kilogram and one for this one. If you see these two equations, LHS are same, right? What I need to find out? I need to find out acceleration. Acceleration of this 2 kilogram block, which means A1, which means A. So I need to find out A. So LHS of the equations are same. What I can equate? RHS I can equate. You are right. Very good. You are right. RHS I can equate. So I am going to equate the RHS of this part. RHS. What is RHS part? First equation is 5a. Next equation is 2g minus of 2a. Take it left side. 7a will be equal to 2g. A will be equal to 2g divided by 7 meter per second square is the answer for my questions. Let me see my answers are correct. Perfectly. It is correct. 2g divided by 7 meter per second square. So 2g divided by 7 meter per second square is the answer for this question. Okay. Okay. Whenever you see some complex questions, you don't know what is A1, you don't know what is A2, you just assume A1, A2, you find some relations, apply that relations in the free body diagram of the concepts. Okay. So fifth example over. Then we'll move to our next example. What is our next example? Example number 4 or 5 or what I have to? I forgot. Totally I forgot. I think 5 is over, right? I think so. Okay, because I rubbed the number. Now I don't know what is that number. What I have placed will be here. But okay. Number doesn't matter. We'll move to the next question. I think it is example number 6. Okay, so no worries. Example number 6. So example number 6 diagram is like this. One pulley, one movable pulley will be here, and this is connected over a fixed pulley will be like this, and this is also connected with another blocks will be here, and 2 kilogram, and this will be hanged with another mass of 1 kilogram block. Okay, question is asking about find the acceleration of. Okay, question is asking find the acceleration of 2 kilogram block. Find the acceleration of the 2 kilogram block. That is a question. What we need to do, this is not like our simple system, right? This is a flexible system. A flexible system means this is a movable pulley. This is a movable pulley. But this is a fixed one. This is connected. This is fixed. This cannot move. This can move up and down. So 2 kilogram will move downward. So we have to see what we will do. As I told before, first we will mark a tension. So I'll use another color. So it is easy for you to catch it from the board. This is tension. This is tension. This is tension. Tensions are always away from the body. So these T together for this body, what will come? 2T. Okay, now we have to mark the accelerations. We know 2 kilogram blocks are moving downward. I am assuming this acceleration is A1. If it is moving downward, means the complete system will move upward, which are moving with an acceleration of A2. Okay, so now you don't know what is the value of this one. We'll use the concept called the sigma. T into A will be equal to 0. Okay, this is our third rule. We'll apply this rule. So first T into A1 opposite direction, so cos of 180 plus second one 2t upside into acceleration is A2 same direction, cos 0 will be equal to 0. So t A1 minus plus 2t A2 is equal to 0. T get cancels. So I can say A1 will be equal to 2 times of A2. A1 equal to 2 times of A2. A1 equal to 2 times of A2. Okay, that's all. So we have a relations. Now we are going to do what? First we find the relations for a complex system. Then what we need to do? We need to apply the formulas. Okay, so first one is free body diagram of which one? Which one? Anything. 2 kilogram will draw first. So 2 kilogram. So 2 kilogram will be here. Tell me the forces 2g downward. Accelerations what? A2 or A1? A1 downward. Tension is upward. Okay, now it is like a song. T minus 2g is equal to minus 2a1. Why minus 2a1? Because a1 is in the downward directions. So tension will be equal to, take it to the right side. So 2g minus 2a1. This is our first formula. Keep it here, number 1. Number 1. Okay. Next, free body diagram of, I need the free body diagram of the second block. What is the second blocks will be here. Okay, so free body diagram of 1 kilogram. I need 1 kilogram. Come on, 1 kilogram, 1 kilogram, 1 kilogram. Upar se 2t, niche se how much? 1g. Okay, so 2t upward forces, 1g downward forces. Adukapram 2t, then acceleration in upward A2. No space to write the formula. Okay, so what we'll do, I will clear this side. Okay, so this formula alone I am keeping it here, else I will forget. I don't have a good memory power as like you. So A1 is equal to 2A2, so I keep it there. Okay, okay, then this is A2. Okay, sure. Then I will write the formula. 2t minus g will be equal to 1a2, so which means a2. So 2t will be equal to a2 plus g. 2t is equal to a2 plus t, and t is equal to a2 plus g divided by 2. Second equations, both equation LHS are same. What I have to equate? RHS I have to equate. So RHS equating a2 plus g divided by 2 is equal to 2g minus 2a1 divided a1. A1 is equal to 2A2. A1 is equal to 2A2. So I can substitute maybe for A1 or A2. Anyway, okay, I am substituting for A1. So A2 plus G whole divided by 2 is equal to 2G minus of 2A1. 2A1. A1 equal to 2A2. So 2A2 substituted here. We have to simplify this one, right? Okay. So hope you have written the right part. If not, pause the video and complete the notebook. I am moving towards right side. Okay, fine. Okay, fine. So A2 multiplying towards right side. A2 plus G is equal to 2 into 2 for G. 2 into 2 4, 4 into 2 8, so minus 8a2. We'll keep this guy towards left side, so we'll get 9a2 is equal to this g towards right side, so we'll get 3g. A2 is equal to, a2 is coming, 3g divided by 9, so which means g by 3, a2 is g by 3. What we need to find out? A1 is acceleration of this block. So A1 is equal to 2A2. What is 2A2? 2 into A2 means G by 3. So 2G by 3 is my answer. 2G by 3, 2G by 3, 2G by 3 is my answer for A1. Okay, hope you understood, right? Yeah? Okay, so find, we are finding the acceleration of A1. So steps will be common. Steps will be, you may get like 2 blocks, 3 blocks, a very complex system. No worries, you just give A1, A2, A3, A4. You find a relations between them. You draw free body diagram of each block. If it is acceleration, tension equations for one body, tension equations for other body, you can equate these two. So let me see, my answer will be correct. Accelerations will be equal to g by 3 for this one, and this will be equal to 2g by 3. Exactly right answer. So the same things you can do, it will be here. It's not a difficult stuff. But yeah, practice is much more important. If you see like multiple questions will be like this one. you will be an hero for this chapter. Okay, so example number 6 over. Next example, tell me example number 7. First I will change the number, else what will happen? I will forget the number, you will remember the number. That is a problem. We'll go to example number 7. 7, 7, 7, 7, 7. Come on, 7. Come on, come on, come on, come on. Come on, come on, come on, come on, come on, come on, come on. Seventh question, come on, seventh question is coming. Coming. Seventh question is coming. Okay, seventh question is like this. One block is placed, Shopa. Second block, it is coming down with a pulley is connected here. Pulley power. Then one body, one pulley is connected here. Okay. Then over the pulley it is going upward, this pulley also power, and what will happen, this is tied here. So poor man, he cannot move upward, he cannot move downward. What is the mass? 1 kilogram and 3 kilogram. This is 1 kilogram and this is 3 kilogram. They are saying I fixed like this. This is the situations. What is the question? Finally, what is the question? Question is, find the accelerations of 1 kilogram block. Okay, so we'll write the question will be here so that we can save the space. Find the acceleration of 1 kilogram block. Find the acceleration of the 1 kilogram block. Okay, no problem, no worries. What I will do, I will mark tension, I will mark accelerations. That's all. First we'll mark tension here, T. Okay, better. Instead of V will be here, T. If you mark T by 2 will be here. That is complex, right? So we'll start from here then, T. That you have to think logically, because that itself I cannot say. What's the problem if you mark will be here, T. T means a summation of these two. So it's T by 2, together you will come T. But that is difficult, right? Handling like a T by 2 fractional numbers is always an headache. So T. So this will also equal to T. So this will also equal to T. Now this will be equal to 2T. So here also it is tension T. It is fixed. So acceleration is 0. Fixed means can't move. Acceleration 0. Is it fixed? No, not fixed. Not fixed. This can move downward like this. But it is fixed. So acceleration 0. Here I don't know the accelerations. I just giving A1. I just giving A2. That's all. This I know it is 0. I am not bothering about this one. Maybe this I put it A3. A3 is equal to 0. I am not bothering about it. Now we will see our story. Rule number 3. Summation of tension into acceleration is equal to 0. T dot A. Dot means cos will be there. First one, 2T. Acceleration is downward directions. So 2T opposite direction. So 2T A1 into cos of 180. Opposite means 180 minus plus. Next one, same directions. So T into A2 is equal to 0. Here I have to write one more term. What is called cos 0? I know it is that. T into A2 is equal to cos 0. 2 into A2. T into A2. Same direction, right? This block is moving like this. So T into A2 cos 0. So minus 2T A1 is equal to, not equal to, plus T A2 is equal to 0. T cancels. So what finally I got? I finally got A2 is equal to 2 times of A1. Sharp. A2 is equal to 2 times of A1. Again I am getting. So what we have to do? We have to draw the free body diagram of 1 by 1. Okay. So free body diagram of what one? We'll start with 3 kg this time. So 3 kilogram. So 3 will be here. Jolly. So 3 kilogram. Left side T. Happy. Acceleration A2 happy. We'll write the formula. Tension is equal to total force means only tension. Tension is equal to mass into acceleration. What is mass? 3 into what called A2. Equation number 1 over second one, free body diagram of what one? 1 kilogram block. So 1 kilogram drawn, completed. We'll draw the diagram 1 kg. So 1 will be here 1 kg. Upward 2T. Downward A1, downward 1g, weight mg. Okay, so we'll write the formula. So 2T minus 1g will be equal to A1. What A1? Not plus minus. Why? going down means minus. Okay, so 2t will be equal to g minus a1. So t will be equal to g minus a1 by 2. We have our second equations, equation 1 and 2 same. This formula I will forget, so I am writing here a2 is equal to 2a1 to apply it later. Now I am clearing this board again. Okay, what I need to find out? I need to find out a1, right? a1 is the acceleration of this 1 kilogram block. 1 kilogram blocks. So we have two formulas will be there, 3a2 left side of the first one, and the second one is g minus a1 divided by 2. Okay, a2 is equal to 2a1. So a2 comes substituting 2 times of a1 is equal to g minus a1 divided by 2. Multiplying to this left side. So already 3 into 2 6, 6 into 2 12. So 12a1 is equal to g minus a1. Take into left side. So 13a1 will be equal to g. a1 will be equal to g by 13. Pakka answer, pakka. Answer pakka, answer pakka answer. A is equal to g by 13 for this one. Which blocks? Which blocks? Acceleration of the first one, the first block, I mean this 1 kilogram blocks is g by the, what is the acceleration of this one? A2 is 2a1. 2a1 means 2g by 30. Pakka answer. So that's the thing. Tension into acceleration 0. If you see like a big complex question in your question paper, do not turn the page, answer it. Very simple method. Okay, normally we have a tendency, like if you see a big paragraph kind of question, not anyway such kind of question, there is a less chance to ask for board examination, but for entrance examination, especially for JE students, normally if you see such a kind of paragraph kind of questions, what they will do? Appa, gone. That feel will come and you will turn the page and you will go to the next simple question. Do not do that. Okay, answer it. This is your rank deciding question. This kind of models, complex stuffs will be there, means you should be happy because you are strong in that area and you are answering. Only very few students are answer such questions, means that are the rank deciding questions. In a physics simple questions will be there, average will be there, very difficult questions will be there. So very difficult question means it is not difficult. The way in which we are learning is difficult. Now you know what to do. So you must have to answer. Then only this you will come to the rank deciding kind of question from this chapter itself. Okay. JE students, this is really important. Neet students also, this is important. Something tricky will be there. Okay. Everybody cannot answer it. So only few pool of students will answer. You should comes in the pool of students in that cases. Pakka, perfect. Okay. I have something for you. Okay, example number 7. I will first change this number, else I will forget the number. Example number 7. I'll make this as example number 8. I will forget the number. You will remember, right? Then you will ask, yes, 7. After 7 it is 8. After 8 maybe I will write it 10. So I don't want to avoid such things will be here. Okay, we'll do one another question. This is a question which is already came for your JE examinations. If it is comes as JE means NEET student should not be happy. Okay, this question will also come for NEET examination also, because both are conducting by central board. So central board is preparing the questions for JE, central board is preparing the questions for NEET also. So the same questions might be come, but not exactly like this. Maybe they will change the values. I have seen there are questions will be there for NEET from JE papers, but not as like exactly. So we'll do what we'll do. I have to draw the diagram first. Okay, lot of diagrams. I will not remember every diagrams. That's a problem. Okay, we are human beings, right? All architectural diagrams. How I can remember? 2. So this is coming like this, and this is fixed over, because diagram is important. If diagram is changed means everything will go out. This is 1m, this is like a 2m, and this is just come and fixed will be here. This is just coming and fixed will be here. Okay, this just tied will be here, that's all. Okay, this is just come and this is just tied will be here. Okay, question is, find the acceleration, anything they can ask, right? Find the acceleration of 1m. What we'll do, first we have to mark tension. We'll mark tension. This is T, so same drop. So this is T and this is T and this is 2T. This acceleration downward A1, this accelerations A2. First rule, summation of T into A will be equal to 0. So first T, so T dot A1, so T A1 cos 180 plus same acceleration, so 2T A2, I'm giving A2. So 2T into A2 into cos of 0 will be equal to 0. So T A1 minus, so minus T A1 equal to minus T A1 equal to 2T A2. TT get cancels. A1 will be equal to 2 times of A2. Jolly. We got on beautiful equations. A1 equal to 2 times of A2. What will do? Free body diagram of M1. M1 means 1m. First body. Tell me T minus downward mg is equal to ma downward, so acceleration is negative. So T is equal to mg minus ma, equation number 1. Second one, free body diagram of 2m block, only tension and accelerations A2 in this directions. So here I have to change the acceleration. What is the acceleration? A1. So what is the formula? It is 2T will be is equal to mass into accelerations 2ma2. 2 get cancelled, 2 gets cancelled. T is equal to m times of A2. Two equations, equation number 1 and equation number 2. LHS and RHS are equal. I need this one. A1 will be equal to 2A2. We need to find out A1. That's our aim, right? A1 is acceleration of the first block. So to formula we can equate LHS. So mg minus ma1 is equal to ma2. A1 I am substituting mg minus m into a1 is 2a2 is equal to ma2. M cancels. So G is equal to A2. Here 2A2. We'll take it to left side. So 2A2. So 3A2 is equal to G, which means A2 is equal to G by 3. What we need to find out? A2 or A1? We need to find out A1. Find the acceleration of 1m. So A1. So A1 is equal to 2 times of A2. So 2 times of G by 3. Answer is 2G by 3 pakka. 2G by 3 pakka. We got the answer 2G by 3. Answer is 2G by 3 pakka. Okay. So tension into accelerations we have equated and we find that question or that answers also ourselves. Okay. So it is 2G by 3 for A1. Okay. Hope this is clear to you. Okay. So we are at example number 8. Okay. So we discussed till example number 8. We'll go to example number 9. So write down example number 9. Okay. Example number 9. Example number 9, there is a little complexity in the diagram, but our same concepts. So once we do this one, you will be thorough with the free body diagram. Okay. So let's do. So we have a fixed pulley like this, and which is connected with 1 kilogram of mass, 1 kg, 1 kg. And this is now going and connected with another pulley like this. And this is a movable pulley, and this is connected with another mass. This is 2 kilogram and this is 3 kilogram. This is one. This is fixed pulley and this is a movable pulley. So this can be moved. Now the question is asking like question. We will write the question. I am writing the question so that I can use that space for our beautiful answer. Okay. So what is the acceleration? What is the acceleration of 1 kilogram block? What is the acceleration of 1 kilogram block? They can ask anything, right? They can ask about tension, any stuff. doesn't matter, but here we have to find out 1 kilogram accelerations. Okay, so let's start. I'll take another pen and we'll start. Okay, what we have to do first steps, this we will do together. Okay, you don't want to listen, we will do together. So once I am writing the board, immediately you will also write along with me, then we will see my answer is same as your answer should be correct. Okay, so what will mark? Here we'll mark tension here, here we'll mark tension here. You can start from any point. So T and become 2T. This is the same rop, so this will also have 2T. Okay, so tension we have marked. Our first step is over. Second step is what? Accelerations. So I know this will be moving upward, so this acceleration is A1, and the complete system will move down, and this will be moving down with an acceleration of maybe A2, and this 2 kg will move with an acceleration of A3 like this. Okay, this is a complete system. The whole system will move like this because here weight will be higher, and within the system for 3 kg will go down and this 2 kg will go up. So everything we mark it. What is our final steps? Summation of sigma of T into acceleration is constant, T dot A. Okay, so we'll start from here. Tension is upward, so 2T A1 into cos of same direction means cos of 0 plus second one is this mass. Here T into A3 same direction, so T A3 cos 0 plus the last term opposite directions, so T A2 into cos of 180 is equal to 0. It's the equation and the expansion here. Okay, so what we'll do, all T will get cancels, so this become 2A1 and plus A3 and T A cos 180 is minus, so minus A2 is equal to 0, or I can say 2A1 plus A3 is equal to A2. This is the relation connecting between all the acceleration. This is what we need. Okay, so we first find what is our next steps. We have to draw free body diagram for this. So we'll start with first one, free body diagram of 1 kilogram. So we'll draw 1 kilogram like this. This is 1 kilogram, and we have to mark all the forces. Here it is 2T tension, and acceleration is upward directions A1, and his weight is called mg, which is called 1g in this directions. So what is the next steps? We have to write the formula. Okay, so tell me 2T minus G is equal to MA. MA means 1A1. So A1. This is equation number 1. So next we have to do the next free body diagram. Free body diagram of which block? Free body diagram of 2 kilograms will write. So I'm writing here free body diagram of 2 kilogram. Okay, free body diagram of 2 kilogram first will write. So 2 kilogram block will be here. This is 2 kg. So the force downward direction is 2g, and the upward, what are the things will be there? Tensions will be here and A3 will be here. Okay, so we'll write the formula. Tell me T minus 2g is equal to how many times of A3? 2 times of A3. MA. M means 2. So 2 into A3. A in the direction upward, positive y direction. So it is positive. 2A3, equation number 2. Okay, and so free body diagram of 1 kg, free body diagram of 2 kg. Will be here. Next one, the free body diagram of 3 kilogram. Free body diagram of 3 kilogram. What all the things will be here? We have a 3 kilogram blocks, and weight will be there at 3g, and tensions will be upside T, accelerations downside A2. We'll write the equation, right? T is positive, upside positive, downside negative. T minus summation of forces. So T minus 3g. T minus 3g is equal to total force is equal to MA. M is what? 3. So it is 3A2. A is positive or negative? Negative, because it is going down. So this is our third equations. So we have three body diagram, and we have a set of equations. Now I am clearing the board from here because I need some space to solve this one. What we need to find out? We need to find out the acceleration of 1 kilogram block. Acceleration of 1 kilogram block is what? A1. So our question is to find out A1. So I am just writing, not to forget A1 I need to find out. I am putting it here. Okay, then what I am going to do, I am substituting in this equation. I have three equations are there, and this is I am giving equation number A. So what I am going to do, equation number 1, equation number 2, equation number 3, everything I am substituting in equation number A. Okay, so 2 times of A1 means what is from this diagram? Okay, 2t minus g, and plus A3 means what? A3 is this one. So A3 means this is 2A3 means t minus 2g by 2. So t minus 2g divided by 2 is equal to A2 means from here we have to find what is that. A2, t minus 3g whole divided by how much will come? Minus 3 will come, right? T minus 3g divided by minus 3 is equal to A2. Here it is A2. This one is A2. We are substituting for A2. Now we have to simplify this, and we have to find the answer for the rest of the things. Okay, so I need to find out A1. So if you see these equations, what parameter I can find from this equation? I can find a tension. If I get the tension, if I substitute, the tensions will be here. I have to find A1 because my final aim is to find out A1. So I am simplifying this. So this area I am clearing it because I need to find out A1. Okay, so I need to find out A1. Okay, I am multiplying this 40 minus 2g plus okay, instead of doing like this we will reduce one step, we can multiply this way. So 2 into 2 4, so 2 into 2 is 4, so 4 into 2 means 8t minus 4g plus t minus 2g whole divided by 2 I am taking as LCM. Okay, then t minus 3g divided by minus 3. 8t and t, how much will come? 9t minus 4g minus 2g minus 6g divided by 2 is equal to t minus 3g divided by minus 3. We will do cross multiplications. We will do a cross multiplications like this. So what will come? Minus 3 into t minus 27t minus 3 plus 16g is equal to 2t minus 6g. 2t minus 6g. All t terms I am taking to left side. So this 2t, so minus 29t is equal to 16g taken to that side. So minus of 22. 16 plus 60 means 22g. Minus and minus become plus. So t become 29. Sorry, t become 22g whole divided by 29. This is the value of t. Okay, now we got a t. What we need to find out? A1. This is a little complex in the sense number of steps will be higher, concept will be the same. First we will do summation of t dot a will be equal to 0. We will find the relations between a1 and a2, a3. Then we will draw the free body diagram for each of this one, and we are substituting here. That's what we are doing here. Okay, so fine. So now this area I am clearing because this is not required. Okay, so what we required, we need 2t minus g is equal to a1. So I know a1 equal to 2t minus g. This is our equation number 1. Will substitute will be here. So a1 is equal to 2 into t. T means 22g divided by 29. 29 minus of g. So 2 into 22. Any mistakes will be here. Let me revisit the steps once again. 2 into 2t minus g, t minus 2g, 2 by t, t minus 3g divided by minus 3. So 2 4 8, 8g minus 4g plus t minus 2g divided by 2 equal to t minus 3g. So 8t and 9t minus 4g minus 6g divided by 2, t minus 3g divided by minus 3. Minus 3 multiplying minus 27t and 27t minus 3. Here it is a difference, right? Here it is a difference. Here it is a difference. So we should be make sure the steps. Here it is a difference, right? Here in these steps, minus 27t minus 3 into minus plus 18g, not 16. I put 18. So 18g, and this is equal to 2t minus 6g. Fine, perfect. So 2t is taken to left side. So minus 29t. This will come to left side and this will go to the right side. So minus 24 times of g. So t will be equal to 24g divided by 29. Okay, now we'll substitute in these equations. This is 24g divided by 29. So we'll substitute this become 48g divided by 29 minus g. So we'll simplify this one. This become 48g minus 29g divided by 29, which is equal to 48 minus 29. It's become 19. So 19g divided by 29 is the acceleration of the 1 kilogram block. This is our final answer for the questions. Okay, hope this is clear to you. So 48g minus 29g whole divided by 29, and we got 19g. Step is correct, right? 48g, 29, 19, 19g divided by 20. This is the acceleration of A1. Once you got A1, you can also find A2. You can also find out A3. This is a little complex because there is a 3 blocks will be here. So far, whatever we have seen, there are only 2 blocks will be there, but connections are little complex. But here we have totally 3 blocks will be there. So any number of any number of pulleys or any number of connections they can make, but your first aim is to, you have to assume the accelerations are independently. Definitely you will get a relations connecting between all these bodies. You will keep it in one side, then you are drawing the free body diagram of each of these bodies and you're finding the answer. Hope the 9 examples whatever we have solved will be here. All the 9 examples are very clear to you. If not, watch it, stop the videos, watch it once again and make it the steps will be very clear. Okay, this is the very fundamental topics based on the problems. Okay, loss of motion is completely with the problems. Now we have learned about how to draw a free body diagram. For any questions whatever given to you, some cases you can always use our shortcut method to find out acceleration. What is the shortcut method? Forward force minus reverse force divided by sum of the masses for acceleration. What is for tension? Forward force into reverse mass plus reverse force into forward mass whole divided by sum of the masses, sigma m. That's all. This is, we can use it for a simple kind of system. When you see the problem, when you see some diagrams itself, you will remember. But yeah, again, of course, practice is very important. So hope you understood the 9 examples today we have discussed. This is the heart of these chapters, like stacked bodies, pulley cases, connected bodies. Enormous things will be there, and we have last one problem will be there, and with that problem we will wind up for today's sessions. Okay, the last example from this one, that is our example number 10th example, the final one. Then the story is over here. Okay, so this is maybe example number 10 is simple to you because you have already seen many difficult things already now. Okay, so this will be maybe you feel it's simple. Example number 10, the last cases. We have a 1 kilogram block and we have a 2 kilogram blocks and we have a 3 kilogram blocks. Tension is T1 and tension is T2. We are pulling with the forces of 60 Newton. Okay, there are question will be here. This is over a surface, right? Okay, this is over a surface. The question is 2 things. Find the acceleration and T1 divided by T2. This is a question. Find the acceleration and T1 divided by T2. This is a string and we are pulling 3 kg, 2 kg, 1 kg masses are connected. First, what is our first steps for this kind of questions? What is the first steps? We have to draw the free body diagram. Definitely it is sure. First we have to find out A, acceleration for all connected body. What is acceleration? F total divided by M total. Total force by total mass. What is F total? 60 Newton. For all this thing, the total forces are acting is 60 Newton. While I am taking the theory in the last session also I told, right? Total mass is of 3 plus 2, 5, 5 plus 1, 6. So it is 10 meter per second square. So we got accelerations. We'll go first one, the free body diagram of. So acceleration, first part we have already answered, 10 meter per second square. And free body diagram of 1 kilogram mass we are going to draw. So 1 kilogram. We know mg and reactions will be here, but that is nothing to do with the tension. So unnecessarily or unwantedly, I am not mentioning like 1 mg and a normal reaction. Nothing to do. It's waste. So what all things is required will be here? T1, the body will be moving with an acceleration called A. So can you tell me what is T1? Total force, only one force. Total force equal to ma, mass into accelerations. Mass into acceleration means 1a. So T1 will be equal to 1 into A. A means what? 10. So 1 into 10, which is equal to 10 meter per second square. Not meter per second square. Tension, right? Tension unit is what? Newton. Sorry. Newton. So this is over. Next one, I'm going to do the free body diagram of 2 kg. You can draw any free body diagram. We have to find T1 and T2. That's all. So 2 kg drawing. So 2 kilogram. This is a force called T2. Left side a force called T1. Tension forces are away from the body, not towards the body. Away, always away. So acceleration is in this direction. So tell me, T2 minus of T1 will be equal to mass into acceleration. Right side, axis. This is positive x minus x. This is positive y. This is minus y. Positive direction positive. So this is in the positive directions. Positive x direction. So it is positive. T2 minus T1 is equal to ma. M means 2. Acceleration positive x direction. So it is 2a. T1 value already I know. T2 minus of T1 value 10 is equal to 2 into accelerations value 10. So we'll simplify. T2 will be equal to, this is 20. This will take into right side. So 20 plus 10. What is T2 value? 30. Question is asking the ratio of T1 divided by T2. So T1 divided by T2. T1 is how much? 10 Newton. Okay. T2 is how much? 30 Newton. Here 30. So the answer is 1 by 3. So we got two answers. One is for acceleration and one is for tension. Acceleration is 10 meter per second square and tension is 1 by 3. The ratio of the tension. This question is always speaking about what is called tension. Tension forces are always acting away from the body. Rule number 2, second rule. Hope you understood for today's sessions. 10 problems. 10 types of models we have seen with the different aspects, with the different rules what we have seen. Okay, so enjoy and have a nice rest of the day. Bye bye.